mostly because one of the companies I worked for, I was the only person knowing MySQL, which doesn't mean that I knew MySQL well, but I was the only one who knew a couple of the parameters, and they said, okay, so from now on, you own this. So that's how I became DBA in early 2008, 9-ish. Since then, I was working with a couple of big companies. You can see Booking, Dropbox, Salesforce. And I had a chance to see how you can improve your systems. Having said that, a disclaimer, this is a presentation from me. Whatever I say is my opinion, not reflecting any of the companies I've been before, just a legal disclaimer. So, let's dive in. So, why do we want to automate? Right? That's basically the primary question. And let me give you an anecdote before I dive in. When I started at Booking, we had about 600, 700 servers, MySQL. And fortunately, they just finished the 5.5 upgrade, which took them 9 months to upgrade that 600 servers, because it was a very cumbersome process, right? You had to remove it from traffic. You had to stop it, start it, warm it up, and everything was manual. A couple of years later, we were over the thousands range, way over the thousands range, and we wanted to upgrade because there was a very bad bug, 5.6 whatever. So we changed our desired version from 5.6x to 5.6x plus 1, and this was in the afternoon. I closed my laptop. Next day morning, 2,600 servers were already on the desired version. So that's how powerful your automation can be. And even if you're not at the scale of Booking yet, I get this from Forbes, so I really hope this is true. Generally, this is the stage a company is going through. You have that early years, but you get into this hockey stick growth. And every company I'm talking, they always do the same thing. They grow faster and faster. I know companies who are measuring the growth of the growth. And that's the KPI, right? Crazy. So whatever works, ooh, that black doesn't really. It's good that only I have black at the beginning, so sorry. If you cannot read it, let me know. What you do now is not going to work tomorrow. You cannot just expect to scale by the cloud provider giving you a better instance type, or Intel is coming out with a faster chip or a faster SSD. It's not going to work. You will hit a limit, and that hit is going to be very painful if you're not prepared for this. I think hiring is very hard. I guess a lot of companies you've been to talk, they said, we're hiring because that there is a need for people. We don't have enough people to do the job. And also the other thing, I think the best engineer is the lazy engineer. We do not want to do anything. We just want to see the bird doing its stuff and just lay back and nothing happens. It's enough that we have the pager duty, which keeps us doing stuff anyway. But automation is hard, very, very hard. And it's much harder than the other aspects of the application because of scalability. And the reason for that is because in automation, you have more things to consider than just in your application level. Because wrong direction. You have the number of servers. You have the number of tasks you want to run. You have dependencies. You have concurrency you want to handle. You have synchronization points. You have prioritization. Oops. And all of these, something is good. All of these makes it harder because let's say you have 20 servers. You don't want all of them backing up at the same time because it's going to saturate your network, right? You do not want to get a failover where you're actually manipulating your application topology. You don't want to fail over to a backup host. There are so many interaction points in automation that can go wrong if not controlled properly. So even in the most simplest system you can think of, you're always going to have an amount of tasks M number of hosts, doing interrupts because some things are more important than other, and there are going to be interdependencies. When one task finishes, it's going to start another one. These are the cross calls. You need to take these into account. Like one example, and I was pointed out earlier that I said that a basic system, and sorry, but I wrote 100 hosts. I know most of people don't have 100 servers, but just an example. You have 3 tasks, very basic automation. You really do the basic stuff. Build a new server, failing over if you have an issue, and doing backups. Hopefully this is something that everybody's doing, like backups. Oh, good. Awesome. You only have 2 dependencies, right? You don't want to fail over to a backup host, and the failover needs to start a new server because we want to have, let's say that server is gone, we want a new one. And you have 3 concurrency constraints, only 5 backups can run at a time, 1 failover can run at a time, and there is one more interesting because we don't want failovers happening over and over again, so we want a constraint that 2 failovers cannot happen in a 30-minute window. So, to give you an idea of scalability challenges, I want to point out left side, linear scale, number of servers and the number of tasks you have. The right axis is logarithmic scale, and that's the complexity of your automation. Now the math behind this is a bit arbitrary, but it kind of shows you the worst case, what can happen. And it's only a 30% year-to-year growth. It's not even an extreme stuff. Your number of tasks are growing. I was assuming that in a 3-year term, you're going from 3 tasks to 8 tasks, and you're going from 100 server to, let's say, 220, 230 in 3 years. That's, I think, any company's reasonable expectation. And your automation complexity grows by 3,000 times if you're not careful of how many dependencies you're introducing or how you interact between these tasks. So, how do you do it better? There are a couple of stuff you need to have in your system. From the life cycle, as you go through, you need provisioning, you need some kind of a bootstrapping that starts your server. You need all the traffic control to decide if a server can get traffic, and if I want to get traffic, how do I get there? It can be anything as simple as a CNAME, but you need something to be able to tell the application without rolling out application code over and over again when you have a new hostname. There are maintenance tasks. You know all of these: configuration management, failure detection, failure management, patching. Jesus, all the things that the security guys are always pushing us. Schema migrations, all of those. And you have the monitoring and decommissioning also. Don't forget about that. I'm not going to talk about all of these because each one of these could be a separate presentation, and we don't have that time. So I'm just going to talk about the main stuff, which includes MySQL and that one in bold. The bad news is there is no single off-the-shelf solution that does this for you. However, there are a bunch of tools available, and if you do it right, you put them together well, it will fly. But it's going to be like this. So before we go into the tools, let's just quickly do a categorization of what we do, what we have. So that's my take. I usually look at tools like this, if it's immediate or not immediate. If it's an immediate reaction, it's kind of an orchestration. Whatever you do and it changes something on the system immediately is orchestration. Whatever is not immediate, it's just sort of happening in the background, like configuration management generally, is on the other side. That's later. I do something, and it will eventually converge to that system. In config management, we have the declarative types like Puppet used to be, Chef, and we have the imperative config management systems like SaltStack, Ansible, where you write sequential task what to execute. In orchestration, we have specific tools which are specialized for one or two topics. And you have the generic tools where you can execute stuff on multiple servers. And generally, the imperative config management systems, also general orchestration tool like SaltStack and Ansible. You can use them for both. So let's just get through the easy stuff. Config management, use config management systems. This is what they were designed for. Do not re-implement the wheel unless you want a new config management tool, but we already have a lot. So Chef, Puppet, SaltStack, Ansible, whatever works for you, keep with that. One thing to keep in mind, it's not that simple with MySQL because many parameters are not obviously changeable dynamically, and even if they are semi-dynamic because you don't want to change buffer pool on a production live server. So the generic orchestration tools, here comes Ansible, SaltStack, mCollective, all of these. Very, very good for ad hoc text execution. I need to run this specific command on 100 servers. Very good. When I want to do some complex task, let's say I want to implement a failover logic, but I need to synchronize with multiple hosts, right? I need to talk to my proxy SQL. I need to talk to Zookeeper or Consul. I need to at least handle my candidate master and the master. There are a lot of synchronization. It's very hard to write it, and I know you're going to say that it's possible. Yes, it's possible. It's just a hell of a work, and it's very error-prone to try to squeeze that into the idea of, let's say, Ansible. Right? And the other thing, centralized becomes a bottleneck very, very quickly. How many of you run Ansible? Good. How many hosts you can run it at most? 5? Okay. Somebody more? Yeah, that's pretty much what I can guess. So with all the optimizations, one of the companies I was working for with Ansible, we could get up to 40 to 50, but that was already stretching the server very hard. It's just the way it's done. SSH and all the encryption underneath it, keeping that connection alive is a lot of stress on the CPU. So you either need to bulk it up in small chunks, or you need to scale your config management system or orchestration tool. So you have a scalability dependency there. You need to scale your centralized system with your databases. So there are specific orchestration tools as well, which some of them I love, some of them I even crossed. Just to say that it's there for the sake of mentioning. Orchestrator is a great tool. Whenever you have a chance to grab Shlomi, do it, talk to him. He loves to talk about Orchestrator. Awesome tool. Failover, together with proxy SQL, very, very good. But there is also MySQL Fabric. If you're running a language which MySQL Fabric supports, great. Pacemaker, maybe. There are also other tools which are more, they try to get more the checkbox ticked, like JetPens. JetPens can bootstrap a server for you. It can manage shards. It can move shards around. Great tool, but it doesn't still handle everything. Vitess, MaxScale also, shard management, bootstrapping, all the same thing. So quick overview of the things I know, what use. These companies are also using these ones. I deliberately put CM in config management because unfortunately I cannot share what Salesforce is using, but it's a config management system. You see that most of the companies are picking some tools and build the rest around it. And the reason for that is matching 2 tools or 3 tools is relatively easy. Matching 5 tools, 6 tools, 7 tools, and get all the mindset differences, because each of the tools were written by different people, different ideas. And you need to find the glue to match, to put these all together. The more tools you get, it's harder. So you need to write less, of course, but at the end you need to write more or fit the logic. That's why I saw most of the companies, they had just only a handful of tools, and the rest was custom made. So how you make this glue? How do you build this? Because you need to write this, right? And I'm not going to go into language wars. Feel free to use whatever you want. But I like Python. So one of the main things to start with is, do you centralize or distribute? And centralized is easy. It's easy to comprehend. This is how our mind works, right? We think about what we would do. I log into these 3 servers, I do this, I log into that 5, I do that, and I synchronize. That's my brain. And if I want to implement my brain behavior onto a computer, that's what I would do. It's very easy to monitor because I have one single entry point. And it's easy to enforce concurrency because everything is there. If I don't run 5 process, it's not going to run 5 concurrent. But it's a single point of failure. And there is a very quick complexity explosion. And we're talking about factorial complexity here. The more tasks you have, the more you need to check that, is my backup running? Do I have a failover? Am I building a new server here? Do I have replication lag? And just the ifs and else. I used to have a slide when we were presenting this from Dropbox, how our code for one of the main centralized executor, we had like grow over time, and if else branches. I think you remember, right? And you can track that in Git, that it just becomes this massive if else whatever, and it's very hard to understand. After a while, it gets to 100,000 lines, and just you cannot. And there goes the easy to comprehend part. That's why it's crossed, because it's easy at the beginning, it's going to be hard at the end. But distributed systems are naturally scalable because they scale with your system. Very simple logic, isolated building blocks, everything is there locally, and parallel by design. But here comes the catch. Concurrency can be tricky, right? Because you don't know how many run at the same time. The overall state of the system is very complex. You cannot really go into one place and see what my servers are doing. And it's much harder to interact with. You don't have a single entry point. So let's address these problems. So concurrency handling, semaphores. Bunch of systems provide semaphores or something similar concept. Zookeeper has it, Ansible has it. You can implement it in Redis. You can implement it in MySQL. And that's a pseudocode basically saying that I want for my task ID a backup semaphore which by default has 5 tickets. And if I can acquire a lock on this semaphore, do the stuff. If not, bail out. That's how simple it is. And you don't need to know what the other servers are doing. You don't care, because you just have a simple semaphore in a central place, which, let's say, console. You go to console, can I run? Yes or no? Simple. You run or not? So it's super quick. I don't know if you're familiar with the O notation. It's mostly used in algorithmic complexity. It's a O1 lookup. I never need to go to iterate over servers or iterate over tasks to check what others are doing. So I have a single access point to check no one into other resources, and very easy to understand. So if I go back, I don't think that any code can get simpler than this. But it requires handling obsolete lock. So that's the trick there. We learned that the hard way. That was at booking. If you're interested, I can tell the story after the presentation. So use TTS or use keep alive or something. If you use console, the console implementation of TTL is by default has the keep alive. So if a session expires, your lock is gone. It's great. So I would recommend using something that it has built in, because otherwise it can get messy, but it's simple to implement also in a MySQL. The real-time check, it follows human logic. So again, that's how you would program something, but it gets very complex. The normal complexity is O n times n time m, where n is the number of servers, m is the number of tasks you run. And again, the code becomes messy. So checkbox ticked. Let's go to how do I monitor my system? You need to know the state of each server. And you need to Doesn't matter where you put it. It can be Logstash Kibana, it can be a monitoring system. You can put that in console even because it's a simple keyword. So just know what it's doing at that moment. If it's doing a backup, I should know that it's doing a backup. Or if it's doing a failover, I should know that it's doing a failover. And trace all operations which have been executed very, very gradually. Like who executed it, why, what triggered that execution time, and what was the result. Very important. This is one thing I always forget. We need to know if it was successful or not. The individual server monitoring itself is also very paramount, right? You need to know what your daemon process or whatever locally is being executed is doing. Very verbose logging, because disk space nowadays is free. So just dump everything, make sure you rotate your logs, but be very verbose. Having extra log is always better than missing a line that will make it hard to troubleshoot. And only connect centrally what's globally relevant, because you can, if you do this, you can easily overload your centralized logging system. Instrumentation on that is crucial, and treat your automation with the same criticality as you treat your databases. Because if your automation that manages your database is down, with the same fate, your MySQL can be down, because that's what's controlling your MySQL server. So that's done. So we just need to be able to interact with our automation. And fortunately, there are a bunch of ways to do this. You can do REST APIs, you can do gRPC, you can even do a socket communication with the local process. But try to avoid direct communication between processes. I'm going to get back to why. But that's also going to explode your complexity if you do that. If you really need to communicate between systems or agents or whatever you call them, use some kind of communication channels. Do not do direct contact between servers. And also security people don't like it. So I think this is done. Also another thing, keep every logic simple. Like locally relevant, locally executable, and local control always, because then it is easy. You manage only one server. Whatever you write, it's for one server, never more. You don't manage 2 servers, you don't manage 100 servers, you always manage one server. So we just simply cut the complexity back by a huge margin. Do isolated building blocks. One thing that you write is responsible for one thing solely, but fully. Don't write multiple stuff that's doing stuff and depend on each other. Try to get everything into one piece and use that one piece. So now we have all of the guidelines or principles, how we put this together. So in more details, what we need, similar to before, we need the ability to move servers around. We want to be able to move servers out of traffic, back traffic, move them in a replication topology up and down. You need something running locally. Let's call it deputy, which can be as simple as a cron job that runs every minute, that picks up something from a queue or something, that the next thing that it needs to do. Or it can be a daemon process or anything. Some place where you have your semaphores, console, I mentioned, I love console, it's a great tool, but you can implement that in anything where you want. And you need metrics and log system, where you collect these, and if you really need a communication channel, which would look something like this. You have the database servers, you have all the masters, slaves, everything, or replicating. You have one agent, the deputy, and that's not Half-Life, which also I was pointed out that it looks very much like a Half-Life logo. No, that's a deputy logo. And it connects to your logging system, it connects to your monitoring, it connects to your router, the traffic router, and everything can control the relevant part of the infrastructure, and it works because it becomes easy. So one of these deputies or agents, the internal system I recommend doing is having an agent, having observers, which always looking at the state of the server. These are not doing anything but observe different aspects. Like I put a DB observer and a system observer there. So one is responsible for checking everything that is on the node itself. The other is responsible for everything that happens in MySQL. All of the data is shoved into a data bus or event bus. And you have a dispatcher that can subscribe to this. And you have reactors that react to any changes on that event bus or anything that you put there. So what makes this self-healing? Because the observers report events, and that can be anything, right? It can be that there is a config mismatch between my CNF and the runtime config. So I can have a reactor that applies the config if it can. I can have a missing grant reactor that is going to apply grants if there is missing. I can have the failed master event, which will drive my failover logic. So at the end of the day, what you will get with this is your system is going to converge to a desired state. You don't know when that's going to happen. So that's a note to everybody here. You don't know when it's going to happen, but it's going to happen. For example, backups. One of the things that was hard to get through with this concept is, when are my backups running? I don't know. What do you mean you don't know? I don't know. I just have a check that backups cannot be older than X. And if they are older, I do a backup. So it can be any time, basically. But I know that I can always restore at least an X day old backup because this is my check, and I know my system is working because I'm monitoring it. And I know the logic because it went through integration testing, and there are alerts in place if eventually it is not succeeding in that. So I have my threshold, let's say an example, at 3 days to start a backup. At 5 days, I'm going to have an alert if it ever reaches 5 days. But I still have backups to restore from, so I'm not compromising anything. But it just happens, and I don't have the problem of scheduling backups, which is very, very hard. Daniel, right? Scheduling backups? So one example how this system would work in a case of a failover. So you have the observer checking the slave status, right? And it's checking if it's running or not. If it's running, all good. Just put that onto the data bus. If it's not running, we're going to put an IO error on the event bus. Then the dispatcher knows that my failover reactor is subscribed to this event, so it's going to send to the reactor. The reactor picks it up, checks all the siblings of that one slave that detected the failure, and sees that if the rest of the slaves are also broken. If they are, initiate the failover. If they are not, they are still running, do some rechecking, and if it's behind a timeout, then probably we have a network partition problem because other slaves are replicating why this one is not. I'm specifically talking about IO error 2003, which means not able to connect to master. And when the failover is successful, it puts the failover event back to the data bus, which my new build server can subscribe to, and the whole process can start again. The same thing, dispatcher forwards it to the new server build, and I start building a new server. A MySQL upgrade, very simple. I have a check for MySQL version. Is it correct or not? If it's correct, we're all good. If it's not correct, there is a version mismatch event in the bus. It forwards it to the upgrade reactor. It checks if it has traffic or if it is possible to take traffic. If it is, it's going to say to the data bus, I need demotion. I need to get away from taking traffic because I need to do some work which is needed to restart the server. So that gets into the data bus, and the data bus sends that to the demote reactor. And the demote reactor checks, can I do this? Yes, do it. I can do it. It throws back a warning. I wasn't able to do it. Nothing happens. The system is still in the same place, right? If this is going to run again, it's going to mismatch again. And it will do it again and again and again and again until it will eventually succeed, because it will succeed. But if I change my version to, let's say, 5.7.25 right now, everything is going to start to upgrade at the same time. And this is where the locking and the semaphores come in place. When the demote is about to run, it can have a semaphore that only one can demote themselves, right? Simple logic. Can I demote? No, because somebody else is already doing that work. So back off. And slowly, gradually, everything will get into 5/7/25, maybe a day, maybe 3 days, but who cares? It's computer time, it's not my time. Sure.
Could you go back one slide? So this is a very smart idea to monitor slave instead of master, and I see it scales very well. Orchestrator, on the other hand, it kind of watches centrally.
Orchestrator does the same thing.
Does it?
Yeah. It does that centrally, but it is looking at the same thing. So,
Is an agent on
yes.
server?
Orchestrator has an agent on every MySQL server, and it sends back the replication data to the central orchestrator database. And if it detects that there is a 2003 IO error, so one of the slave got disconnected, it checks all the rest. It used to be. Now it's roughed. So instead of everybody, now it's enough to have majority consensus. So if the majority of the slave says that I think the master is dead, then orchestrator starts the failover. Same idea, yes. The only difference is that it runs the failover from orchestrator node, and it handles from there centrally. What I would do, and what I would say, your slave should drive it. So whichever slave detects that I'm ahead, because you have the GTID position, let's say, that's another thing. So you can have something that writes the GTID position back to the master that replicates back. So I can still observe the cluster health locally without going to other servers, right? So whichever server is up to date, it can check itself that am I the latest slave? If not, back out. And the latest slave can initiate the failover, because most of the things that is happening is local, right? And for example, slaves can react that I'm disconnected from the master, but look, we have a new master. Let's just move there. And all the slaves will be moved underneath the new server eventually, and they can position themselves by GTID. So there are a lot of more things to it than, I didn't want to overcomplicate the graph, but there are a lot of things that can happen by this. So the failover event, when that happens, it can drive the other slaves to move back to the new primary. It can drive your monitoring system or your application or anything that needs to know about this, and you can hook things into it, like webhooks. You can have a PagerDuty alert and stuff like that. So that, some ways it's similar, and yes, it is inspired by orchestrator. I just think that driving this from the slave scales better than driving this from a central point. That's the only difference. No offense to orchestrator. Orchestrator is great. You didn't see the beginning. I said very nice things about orchestrator. Any more questions on this? Yeah.
You said that it should initiate from the slave. So the daemon that's running on the slave, is that going to be doing the elections process of polling the other slaves as well?
No, not necessarily. So as I mentioned, I don't like to control out, only control locally. So what can happen in that case, and in this logic, how this would work is the secondary whatever, the one who can go to be a primary master will do whatever it needs to become a writable primary server, right? But at that point, it may not have enough slaves. A lot of slaves were probably under the primary master, so we need to move them away. So the rest of the slaves, they have the same event. They got the same, not this one, sorry. They got the same IO error problem, right? But what they can check, is there a new primary master? If there is a new primary master, instead of initiating a failover, they can move under the new master. So that would still happen locally, right? I just need to know what is my primary master, and that can again be console, it can be proxy SQL, whichever you want to be the source of truth, it would work. So you can just do console and say, OK, who became the master after the failover? And all of the slaves that are disconnected will just slowly pop under the new master. Did that answer your question? So the benefits of such system is, again, the complexity reduced is great. That's my primary thing on it, that I can explain the even more complex procedures by small steps. And if small steps are good, then it works. And I don't need to write very, very convoluted codes, because every decision in our code base, and unfortunately I cannot share that, but I would love to, but every single decision is an O1 decision. You never have a complex decision-making process where you need to scan through hundreds or thousands or whatever resources to get an information. There is no overseeing authority, very limited intercommunication. So I know that as long as one server works, my whole infrastructure will work. It makes it very, very easy to run integration tests, unit tests, all of those, because I only need really one or two servers to prove that everything works. And if it works on 2 servers, it's going to work on 2,000 servers or 5,000. Yeah.
Get back, how can you find out which slave has the latest? It's like, without comparing the other slaves, how can you know that you are the one that has the most of it?
So one of the things that you can do is write like a heartbeat mechanism. So every MySQL server can write its own GTID position back to the primary master, which is going to replicate downstream. So every server will know every other's GTID position. That's one way to do it. You can also have monitoring.
I was going to ask if you ever use console to deal with that.
Yeah, you can do that with console. You can actually have some kind of a locking in console. I would like to actually investigate that, doing the consensus protocol in console or Raft to decide who gets to be promoted, right? Or you can just go to MySQL. So there are exceptions. So don't take this always as a like a very hard rule. You can reach out to MySQL. So if your server needs to check a slave, let's say your master agent needs to check the slave status on the slave, it's an intercommunication, but it's very limited. So yes, you can have some of these outreach as long as it's very limited and it's not complicating your system. If it's actually simpler, then do that. And actually that was kind of the end of it. So do you have any questions?
Are you using some sort of like finite state machine for all this?
Very good question. I would recommend yes. I cannot say if I do or not. Sorry. Salesforce is very restrictive about what we can share. So this is all my recommendation that yes, do, because it's easy. So many of these that I described in the agent, this, for example, or the other ones, the checks and all of those can be implemented as a finished state machine. The only thing I would mention that if you do state machine, you do one thing always, right? It's unless you're forking off of the state. So unless you have threads there, the state machine is always one thing. So I'm going from, let's say, idle to do a backup. From backup, I come back to idle. But if I'm in a backup state, I'm not going to do anything else but backing up. So it's good. Probably I would not do that on the level of the overall agent, but definitely a very, very good concept to do for such system, because eventually our databases are implementing also a finished state machine. They are going up to primary, coming back, going up, coming back, decommission, new server comes in, do the same dance over and over again. So I would do it on the lifecycle management or something around that.
Because otherwise, if this failed anywhere else, you would basically have to start all over again, right? It would know its last, oh no, console would have where,
Yeah. And also the other thing that was actually presented 2 years ago, at Dropbox, we had a rollback mechanism. So any operations, even including not failover, so because it's very hard to roll back from a failover, but everything else like a promotion, replication, topology changes, all of those were rollbackable. So if you had any exceptions, by any reason, the whole thing went back to the originally last known state, and it wasn't a state machine, it was this state pipeline. If you use Jenkins or GoCD, kind of that concept that you have stages, you have big pipelines, and it always goes back to the latest consistent stage. Yes?
Specifically with the failover situation, how do you handle split brain situations?
My advice is page immediately, because you don't know. Split brain is one of the hardest thing to do right. You can automate it, and you can hope that you're automating your majority of the cases, not the minority. But it's something that if there is a split brain, you have to have people involved. There's no way out of it. And if you're one of the detection is that the slave can check if their other siblings are also disconnected, right? If, for example, you cannot connect to your siblings, that means there is probably a split brain, because chances are that 5 servers or 10 servers or 900 servers in case of booking goes on at the same time is very, very low, right? It's not going to happen. It only happens if you have a network problem. And then you can call the network engineer saying, finally, it's not the database, it's the network.
So you don't have any standard mechanisms like using sort of backplane channels like through your hypervisor, to try to kill the other node or anything like that? You haven't thought?
You can remove from proxy SQL, for example. So whenever there is a failover, and that's the other thing, I always recommend whatever happened, that server is tainted, because you don't know why it happened. And until you do not put it back even as a slave. That server is gone. Just somebody, maybe next day, come in, check what happened yesterday night. You don't have to be paged. You don't have to wake up overnight, but check what happened with that server. And if it's all healthy, if it was, let's say, just a bug, or you hit a ugly something, a segmentation fault in MySQL, or one of the disk got dropped out, replace the disk, put it back.
But that's assuming that there's a proxy SQL like middle layer kind
Yes.
of approach, not like an embedded in the application stack.
True. And we come back to. Nope. Come on. There it is. You need traffic control. Yeah.
But I'm just saying, like, if that's the different architecture that if you actually have like the app, if you think of like the, if you think of a containerized data or application, you
Yeah.
have like proxy SQL embedded in the application. How do you do it?
True, but even then, you have a way to tell that the server is gone, right? If you have, so you need to have something to tell proxy SQL which are the members of the cluster.
Would you use like a console template or something?
Console template is a great example of that, yeah. Console template is awesome to do that. You can also use the ENS lookup of console. I played more with the DNS actually than the template, so I know that I'm more familiar with the console DNS than the template one. But yeah, that's all great options to do. Other questions? I just saw the sign that we have like 5 minutes, so wrap 4. Yes.
So to summarize at a high level, you believe in having a distributed process that handles system management globally, and then you have something that monitors to make sure that that process hasn't gone away
Yes.
and isn't unhealthy. And you rely on the configuration management to push out everything that is ancillary to the
Correct.
what you're trying to do.
Yeah, correct. Absolutely. All the systems I've seen so far, this is the best version that I see working the most efficient way, easy to scale, easy to maintain, easy to add stuff. So the other thing is that over time, you're not going to have 8 tasks in 3 years. That's unrealistic. You're going to have 20, 30, because more people will add stuff to it, even ad hoc stuff. So, and if it becomes easy to add stuff, like just on a Monday actually, I was talking to somebody about a problem, and they had a great idea how to do it. I needed to get some more data, collect more data, and I needed to store that data. Whole thing was 2 lines of code, because all I needed is an observer and a reactor. And if you're doing object-oriented programming or something, that becomes just a skeleton plus a library call. Get this from MySQL, put it on the event bus. And on the reactor, what do I store? Store this, please. That's it. So at the end of it is really, really easy once you get to the point of this working. Getting this done is not easy, I'm not going to lie, but you can get it done in 1 year. Yep.
Quick question, because the teams that you need to implement, deploy, and manage this, can you just focus very briefly on what's in the team, what kind of skill set, what kind of organizations you might need?
That you need to maintain this. So you need somebody to get this, to get the framework working. You need somebody who knows programming well. It's beyond scripting. It's not a simple just I'm writing a couple of. You need to know that. But if you're writing it well, the rest of the team can just really use skeletons, templates, and documentation can be enough that you can use this library, import this, put it there. This is how you access MySQL. This is how you can access configuration. This is how you access our pager duty. This is how you access this. And they can just write a couple of lines of code and extend the functionality whatever they need. So you need a couple of persons who are familiar with these on a deep level and able to change code in the library part of your code base. But I'm also a true believer in separating your library. I don't know how you ask, called like shared storage or the deep stuff, and just publish an API to somebody. They can import from, use it however they want it.
Do you have a CI/CD pipeline around how you're delivering all this
Yes.
code? Okay. And can you talk about that at all?
We have tests, unit tests, and we have quite a high coverage, even though it is infrastructure automation. But if you write it, and that's coming back to why I like separation of libraries, because your libraries are not actions. You can test them with unit tests. And if you do, you can rely on them. And then you just need something to do some integration test on your operative side of the code. And this is roughly what we are doing. Yes?
What is the criteria that you're using for detecting that the master is failed and add that?
The slaves are broken. No. The slaves are broken from the master. So if you monitor the slave status, and
I was going to say, don't base it on just the business lookouts.
No.
It is sometimes really
Yes.
networking, not
Yes, absolutely. So you can look at the show slave status, and if IO thread is not running, you can check the last IO error number, and if it's 2003, it means that it was disconnected. Because there are other ways. It can be max connections, it can be authentication problems, so you don't want to fail over an authentication error. But the 2003 means that it's disconnected. Yes?
How many slaves you need minimum for this to work? So because like obviously one slave is not enough.
Yeah, it is.
But like how would you detect a network partition with one slave?
Then you won't. But if you have only two servers, you need somebody else. So, for example, you can use console agent to detect if it's down or up, because it's going to remove from console if MySQL is not up. That's one way. And if console still says that it's up, then probably it's not crashed, it's a network problem. If you use ProxySQL, you can check ProxySQL if the server was shunned or if it's online or not. There are different ways. You can, you need to get out to somewhere. So if you have two servers, one slave, you can't really have that consensus. You need a second opinion. And whatever you're using, there's always something else connecting to the database. Like worst case scenario, you can check if you have traffic on the load balancer, or what is the status codes you're serving to the client. If it's 500, then it's probably not a network partition, it's a crash. So there are tricks. Yeah, I understand it's not that simple then, but there's always something to bring into the picture to double check that yes, it's down. Any other questions? Then, if you liked my session, please rate it. If you don't, please talk to me outside. I would love to get